Hello everyone, welcome to Omics Odyssey. I am Anisur Rahman, your guide on the journey through the fascinating world of omics data analysis. Let's explore together. Today we are going to learn how to download sequencing data from online databases. I'll show you several ways to download data quickly and efficiently. My plan is to make a small video series for each method. In this video series, I will show you how to download sequencing data from SRA database of NCBI. Next, by using SRA toolkit in command line. Also, how to use parallel version of this tool to download faster. Finally, a more generic parallel script for downloading different types of data. In today's video, I will discuss about SRA database of NCBI and show you how to download your desired data by using a browser. Let's go to Google and search for SRA NCBI. SRA means Sequence Read Archive. It is one of the most widely used database to upload and download sequencing data. Also, don't forget to visit Omics Odyssey GitHub page. You can find all the related course of my videos on this page. For example, you can find the course of today's video on this file under Tips and Tricks repository. I will share the link to this file in the video description. Let's say you want to download the data for this SRA ID. Enter this ID on SRA page and search for the data. In this page, you can find the related information of this sample like name of the sample, name of the sequencer machine, type of sequencing method like this one was whole genome sequencing. The layout type of this data is paired. That means it has one file for forward reads, another one file for reverse reads. Then this sample has one run and this is the accession number or SRA ID of this run. You can download it from this link. We will get to that within a couple of minutes. It has around 4.5 million spots. In simple terms, spot means number of reads. So this sample has 4.5 million forward reads and 4.5 million reverse reads. This data has a total of 1.3 giga or billion bases by including both forward and reverse reads. Next, the file size is just over 550 megabyte and then publication date. Now, at this point you may ask where I can find the SRA IDs of my target samples. Usually, if the data has been published in a research paper, then you will find it in the related paper. But most of the time, authors provide the project ID for the study, and all the sample data is uploaded under that project. Now, let's say you have this project ID, then go to NCBI BioProject database, enter the project ID here, and tap search. The next page contains all related information of this project like title of the study, accession number, related publication, etc. In many cases, especially in transcriptomics and epigenomics related studies, you may find another type of ID which is known as GEO accession number. GEO stands for Gene Expression Omnibus. Based on the type of study, many authors submit their data under this repository. Hopefully, I will talk more about it later in another video. Let's get back to the BioProject phase. If we click on the SRA experiment link, it should redirect us to a page listing all samples sequenced under this project. I noticed sometimes these links do not work. I don't know the exact reason, but SRA has a new different interface to select, filter and download the data more conveniently. It is called SRA RAM selector. Let's go to SRA homepage. Click on SRA RAM selector. Simply enter the project ID here and you will see a complete sample list presented in a clean and user-friendly interface. Here, this is the filter list where you can filter the data based on different criteria. This part contains more information about the data, then size and option to download related metadata as a list. Let's say we want to filter the data based on platform. select platform and then select Illumina under platform. Next, library layout. We want only the paired-end reads. After selecting all the filtration condition, now from this select tab, you can download related metadata or only the SRA accession list of the runs or samples. This metadata contains all the information of this table. You can also select some or all samples from this table. Then click on this selected button and download the metadata or list for only those samples. For now, just click on this run and it takes us to a new phase. This phase contains kind of similar information as I discussed earlier on the previous SRA page, like this sample has one run. In simple terms, run means replicate. That means this sample was sequenced once. Then it has 2 million spots, more than 608 million bases and its sizes, etc. Then it also gives us some estimation about the length of forward and reverse read, and also if there is any variation in the read length. Also notice the line, this run has 2 reads per spot. That means this is a paired end run. Now to download the files, click on this FASTA/FASTQ download tab. The accession number of this sample is already selected. FASTQ is the typical file format for sequencing reads. So just click on this FASTQ tab. Based on the size of the file, it will take some time to download the file. In the meantime, let's talk about another fact. We selected a paired end run to download. So ideally we should have two files, one for forward and another one for reverse reads. But I hope you noticed we downloaded only one file. Then what is this file? For forward reads or for reverse reads? Actually, this file contains both forward and reverse reads. This is the orientation of an interleaved paired end FASTQ file. In FASTQ format, each read has 4 lines. I'll talk more about FASTQ format in detail later in another video. Now, in the interleaved FASTQ file, first we have 4 lines for forward read 1 and then 4 lines for reverse read 1. Then again for forward read 2 and next for reverse read 2. And thus it continues. I hope you got the idea. So, if you download a paired end FASTQ file from SRA database directly, you have to split it into forward and reverse file. Another limitation of downloading data from SRA database is if the file has more than 5 giga or billion bases, you can't download it directly via browser. You have to use SRA toolkit in command line. And that command line code can also split the paired end files altogether. So you don't have to run separate command. I'll show you that in the next video. Now let's see how to split this interleaved paired in FASTQ file in command line. Open the terminal in directory where you save the downloaded file. You can also use cd command to navigate to target directory. First, let's check if we are in the right directory. Type ls command in your terminal and press enter. If you are in the right directory, you should see the file here. To split the data, I will use reformat.sh command from bbmap tool. I use micromamba for environment and package management in command line. If you have Conda or Mamba instead, you can use that. But if any of you don't know what is Conda, Mamba or micromamba is, don't worry. I have already created a video on how to set up your PC for bioinformatics analysis in command line. From that video, you can learn how to install and use micromamba. I will add that video link in the description box. So at this point, I am assuming you have already set up your PC for command line analysis. I have bbmap installed under bioinfo environment. If you don't have bbmap installed, you can use this command to install it. Just a gentle reminder, all these codes are available on my GitHub page and the link is added in the description box. Okay, now let's use the reformat command. So the syntax of the command is reformat.sh, then interleaved file as input, then out1 and out2 for forward and reverse file names. Obviously, you can choose any name that you want. Next, just press enter and run the command. Now, if we use ls command again, you can see we have three files. One original interleaved file and splitted forward and reverse file. As we saw earlier, this sample has 2 million spots. That means it should have 2 million forward and 2 million reverse reads. If you have SafeKit tool installed, you can use SafeKit stats command to check that. Here, asterisk.fastq.gz means anything.fastq.gz. Thus, with such pattern, we can run this command for all zipped FASTQ files in this folder. As I said earlier, the forward and reverse files each have 2 million reads, while the main interleaved file has 2 plus 2, 4 million reads. The total number of base count is over 600 million and each splitted file has roughly 300 million bases. Finally, there is also information about the length of the reads. That's it for today. If you have learned something new and enjoyed the video, please don't forget to like and subscribe. Until next video, goodbye.